So not just for right triangles, but they're formed from right triangles, these two formulas, law of sines and cosines. All right, here's the first one. It's very important. I think we did this back in right triangles where we had like capital A would be a vertex, capital A, B, C for the triangle. But then the opposite side from A is little a. And then the opposite side from B is little b. And the opposite side from C is little c. Because that's important, because they're just going to throw A, B's, and C's up here. You've got to know which one goes with what. Let's see. So here's the formula. And there's three formulas. They're all combined into one up here. Let me break it down. Here's one of them. Sine of capital A over little a is sine of B over little b. So again, that's why you got to know which sides and angles go together. You could also compare B with C, or you could compare the first and last one. Sine of A over A is sine of C over C. I'll show you how we get it in a minute. And I want to say here, it works primarily for these two, and it will also work for SSA a little bit. But the two main ones it works for, angle, angle, side, and angle, side, angle. It will also, again, I'm going to show you in a minute, it will also work at times for SSA, angle, side, side. But not always. That one always gives issues. Okay, let me show you why it works. I'm going to give you a little proof of it. It's very short. Any thoughts before we show why it works? All right. So here's the same diagram. I threw an H there, which is the height of the big triangle. Right, so most of the same setup. I threw in H, and then there's point D. I'm just going to show the first case. Sine of A over A equals sine of B over B. And then all the other two ones are based the same way. All right, so we start with a triangle. I'm not going to write that down, but it would be just a given. The next step would be this. All right, well, I got to get sine of A in there and sine of B in there somewhere. So I'm going to do sine of A and sine of B. All right, if you recall sine, what's that ratio? What size?
Over H.
Oh, yes, so opposite over hypotenuse. Thank you. So you start at A, and it's a right triangle here, right? Since that's a right angle, this one is. I'm only in the left triangle. Earlier students thought I was like between both triangles. No, I'm just in the left triangle. So starting with A, the opposite side, I'm not going to label it, but the opposite side is H. Over the hypotenuse for the red triangle is B. Again, that is just the red triangle, the left. Now, I need sine of B. Well, sine of B is in the right triangle, the one on the right, blue triangle. So let's do sine of B. Sine of B is going to be opposite over hypotenuse for the blue triangle. Opposite is, again, H. Over the hypotenuse this time is A. Okay. Just so you know, I'm going to write over here on the right side what property we really used. Okay, I'm going to write the reasons. I'm not going to do more of an official proof, but I'm going to write it over here. That was just a sine ratio. You could put sine ratio, you could put definition of sine. Either of those is good. Okay. Well, next thing is up here in this formula. There's no H in there. I gotta get rid of H. So what I'm going to do, in each of these, they have an H in them. I'm going to solve for H in each one. Then I'm going to be able to substitute, and it'll basically go away. So I'm going to solve for H here. I need to get rid of the denominator, so I'm going to multiply both sides by B. And same thing on the right side here. I need to get rid of A, so I'm going to multiply both sides by A. Okay, the result here will be B sine A equals H. And then on the right over here, I'm going to have A sine B equals H. So So the B's and A's canceled out in the denominator. That was certainly we just multiply both sides, so that's multiplication property. Okay. We're back from like unit 1. Both things are equal to 180, or here they're both equal to h. Right? They're both equal to the same thing. We set them equal. Yeah. So they're both equal to h. We're going to set the other parts equal. B sine A equal to A sine B. So what I really did was we just plugged this one in over here. We really substituted. So substitution property. And finally, last step here, I got sine A on the left and sine B on the right. That's good. I need them to be alone. I don't want this B and A here with them. So I'll just divide. So on the left side, I'm going to divide. Well, I'm dividing both sides by B. Let's start with that. Both sides by B. Here it cancels. Now I do the same thing on the right side. I'm dividing both sides by A to get rid of this one. That one cancels. And there we go. That's it. So that was division property. So we're good. Sine of A over A and sine of B over B. We got it. I say at the bottom, the other two cases relating B and C or A and C, it's the same thing. You just have different variables. So. Okay, let's try some examples of that. Anything I can answer on the law of sines and how to get it there?
So, well, I don't know.
Right here at the end, I really did division twice. I could have made it 2 steps. But I really divided both sides by B. So that B is just there. But this one canceled out. It's gone.
Oh, there's 2 B's there too. Won't that cancel out?
Here? Oh no, this is sine of B. That's like, you can't break that up. And this is capital B. That's the angle. This is little b. It's the sine. Yeah, so those ones cancel. Now, and then,
I get it.
okay, I was doing the same thing over here with A's. I divided both sides by A. Here it's just there. And then there it cancels out. Yeah, right.
Very good reshoot after a few examples.
Oh yeah, maybe after one. Yeah, good example here. Good, yeah. Sure. Okay, let's flip the page and try one. Solve each triangle means find all the angles and sides, round to the nearest. It's good to see what setup we have. I have 2 angles and a side that's not included. 2 angles, but the S is not between the 2 A's. So it's AAS. So this is a law of sines 1. It's not a right triangle. So I can use law of sines. Okay, well I can actually find the angle first, right? I have 2 angles in the triangle. Just subtract from 180. 17, 29. And by the way, you're going to need a calculator for this, because it's a lot. You set them up and then you plug them in your calculator. So, if you have it on, you get your calculator out so you can try these. Okay, so 39, 46, we got 134. 134. Alright guys, for this one I'm going to, PQ, I'm going to label it ABC just for this first one. But the formula is really pretty easy. You don't need to follow that precisely. So in the future I won't relabel, but I will for this one. So this is A, this is B, and this is C. I'm just changing those, just so it's in terms of the formula A, B, and C. Now, let me label the other sides. Little a would be here, opposite capital A. Little c would be here, opposite C, and B, so little b. All right, now we're set up. Let's do law of sines. How about for this one, I'll go ahead and write down, I'm using the exact formula, sine of A over A to equal sine of B over B. For the next one, I think I'll just do it and not write that first step down. Yeah, man.
How do you know which test to put in your sheet?
It doesn't matter. I just threw in 3 and then, no, now little a, little b, and little c are opposite.
Yeah.
Capital A, B, C.
So it doesn't matter.
No, I just threw them in. Okay, so let's do it now. Sine of A, capital A, that's 17. Over little a. Well, I don't have little a. So, just call it little a. That'll be what we're solving for. Equals sine of b. B is 29. Capital B, 29. Over little b, which is 8. Yep. We get to here. What do you think we need to do to solve for a? Cross multiply, and then we'll often divide. So cross multiply a times sine 29. Just going to be a sine 29, or sine 29a. Here we got sine 17 times 8. I'm going to put the 8 first. 8 sine 17. We're solving for a, so now it's just dividing by sine 29. And you see, I'm not putting these in my calculator until I get to the end. Sorry. So divide by sine 29. Okay. So this will be a. I'm just going to put this in my calculator. 8 sine 17 sine over sine 29. Again, a reminder, be in degree mode. Make sure you're in degree mode. What we got? 8 sine 17.
8 sine 17 divided by sine 29.
Make sure either use the fraction or if you're doing division, put that closed parenthesis and then do it. So, oh,
Sine.
well, I'm just.
4.8.
What is it again? 17?
Divided by sine 29.
Why'd you?
So then you get a
I'm not
equals
top
sine
here.
17, or
There,
equals
right?
17 divided by sine.
Okay, so about 4.8. I'd verify that you got that on your own on your calculator. So
Yeah,
about
it's all for
4.8.
C.
Really, that's rounded. So. Okay, let me do one more. So we solve for that side. To get C, right here is the final missing side. I have to do it again. It's not a right triangle. I can't do Pythagorean theorem. I have to do it again. So I'm going to start it another. Now, watch here. I'm not even going to write down the formula. It's just sine of an angle. Now I need to involve little c. So that means I need to involve capital C, right? Those go together. So I'm going to do sine of 134 over its opposite side, which is little c. And then you just repeat, sine of an angle over its opposite side. And here it doesn't matter because we have 17 and 4.8, we have 29 and 8. I'm going to do the 29, yeah, because there's no decimals involved. Sine 29 over 8. So if you're following the formula, I really did sine of c over little c and sine of b over little b. Okay, same thing now. Cross multiply, I'll have c sine 29 equals 8 sine 134. I got to solve for c, so then I divide by sine 29. Yeah, thanks. So that about 11.9.
Yes.
Okay, and then we solve. We have all three angles. We have all three sides. So first example of that, anything I can answer? Okay. What I'm going to say next at the bottom, I'm not going to talk too in depth about it, but do you remember how side-side angle, also known as angle side-side, caused issues? And it wasn't one of the four, or well, five I think, Chelsea. It wasn't one of the four main ones we used for showing triangles congruent. Didn't work. Same thing here. It causes issues. It can work. So you could have one triangle, it does work, law of sines, fine. It could also be a triangle that doesn't work. 0 triangles that could work. It could also be one where there's 2 different triangles. We did this with constructions. where we were drawn in the last like arc, and it made two different triangles that would form when we did an angle side side. So there's issues. Basically, I'm going to show you one here in a minute where we can do law of sines, but it shows you it wouldn't be a triangle that works. So for example, what I'm saying right here is angle, and then they do side side. So what if I gave you a triangle and this angle's 70, this is 5, and then they say this is 2? That triangle just doesn't actually work. Because, I mean, think about it. This is 70, and this is 5 up. It's going to be like that. That 2 can't reach all the way down. Or maybe if the angle was smaller, it could. But in this case, yeah, it couldn't. So that would be a triangle that doesn't work. And that's just the case angle side side. If that's all you're given, it might not work. Okay, let's move on from that. Next page. I'm going to set up one part or two, not going to finish it, and then we'll quickly do number 3. So, in number 2, let's see what setup we have. 2 sides, angle not included. 2 sides, angle, I'll put it over here, not included. So it's side side angle or angle side side setup. So we can try law of sines. It might work, it might not. Okay, here's where I'm not going to relabel ABC. I'm just going to do the formula. Sine, so there's law of sines I can try. Sine of one angle. Well, I only have 39. So I got to use that one. Its opposite side is 28 in length. Equals, then I do sine of another angle. Which angle should I go with? Yeah, R, because if I did P, I wouldn't have little p over here. So I got to do R over little r, which is 41. So the thing you'll notice that's different about this one is the variable, instead of being here, is one of the angles. We'll solve for it almost the same as our last step. We'll need to do something different. Okay, so let's go ahead and start cross multiplying. I got 28, and then sine of r. And then here I've got 41 and sine 39. Alana, question?
Yeah. So how do you know which one's A and which one's B?
You can feel free to label these. Like you can just call anyone that you want
So
A.
you can
B,
just
C.
label anyone
Yeah.
A, B, or C.
Yeah.
So you can label
But-
any one of those points A?
Mm-hmm.
Okay.
And you feel free to do that. I'm just not going to because really it breaks down to this. Sine, pick an angle. And then underneath it you put its opposite side. Put OPP. Sine of it, one angle up there over its opposite side. That's what the law of sines basically is. Yeah, you can definitely do that. So cross multiply. I'm solving for r. I first need to get rid of the 28. So I'm going to divide both sides by 28. Again, don't put this in your calculator yet. I guess you could on this one now, but I'm not going to. So I'm not going to write another step. I'm just getting rid of that 28. All that's left is sine of r. What do we do to get r? Inverse, nice. No angle, sine, cosine, tangent. No angle not occurs. Do the inverse. So we'll do sine inverse to both sides. And on the left side, it cancels out. We'll just be left with r. And on the right side, we're going to be rounding, so I'm putting about equal to. And we put this in our calculator.
Wait,
Yeah.
you're doing the inverse because you're trying to get an angle?
Yes.
So do you do
Not
41
Correct.
parentheses?
Well, I do first
got it.
second sine to get sine inverse.
Yeah.
And then I do, what was it, 40?
41.
41 sine.
41 sine 39?
Yes.
29.
39.
39.
Oh, I got an error.
Then put another parenthesis.
Close parenthesis there, yeah.
Divide by 28.
Then divide by 28. You can also have done a fraction inside the sine inverse.
67.14.
Yeah, 67.11.
That's good. Now, Yeah, if you wanted to as well, you could have just done the 41 sine 39 divided by 28, get a decimal, and then do sine inverse of that.
You do 41 divided by 28, you said.
You could 41 sine 39 over 28. You could get a number there first, then do sine inverse of that.
Wait, I thought you were gonna do sine inverse for the.
I did on the outside.
What about the one in the middle?
It's doing sine inverse of all of that. Okay, but feel free to do the inside first, and then do sine inverse of that. But again, good job. Yeah, it's good to check here so you can do it on your calculator. What was it in 67 point?
1, 5.
Okay, well, I think it's a nearest 10. So. Okay, I'm not going to finish this one, but you would subtract from 180 to get angle P.
73.9.
And then you do what we did on example 1. Let's put example 1 to get this side.
Okay.
67.1. Let me move on and finish up with 3. Given triangle, the following triangle, I should say it's triangle ABC. Sorry about that. It's triangle ABC. Just make a little drawing here. With those 3 things, 2 sides and an angle given, find or solve the triangle, still the directions. So little a is 3, opposite big A. Little c is 1, opposite big C. And then c is 50. Hey, good point. Isn't it kind of what I said before? If this is 50 and this is 3 up, can 1 really reach all the way down there? It's not going to be able to, yeah. So we'll see that in a second.
Yeah, I was like, how do you know?
Yeah, the math will work itself out here in a minute. So just to clarify, this is 2 sides and an angle not included. So it's not an angle side. But I'm throwing you this one because it's a little different. It's not going to work. I remember with angle side, sometimes it does, like in number 2. Sometimes it doesn't. So what did I want to say? So let's set this one up. We can use law of sines. Sine of one angle, 50, over the opposite side, 1 equals. Then I do it again.
Sine of A.
I have to choose A because I need the 3. If I chose B, I wouldn't have little b. So sine of A and opposite A is little a, which is 3. Now we cross multiply here. 1 times sine A is just sine A. And 3 times sine of 50 is 3 sine 50. So I don't need to divide. The last one we had to divide by 28 first. Here we don't have to. It's just sine of A. So now I do sine inverse.
Error.
And it's going to give you an error. So that's what I was saying. The math will work itself out that it didn't work. It's not a triangle that would work.
What would you write?
No solution. Or you can even describe, hey, this is a triangle that doesn't work. Good work. How about